Good afternoon, good evening, wherever you are at. I hope you are doing great. I am going to attempt to quickly go over the homework from last night's practice problems and make sure that you're on target, and then you can move forward with today's lesson here. So, and looking at number 26 here, guys, what we know about all four of these problems is that we have four parallelograms, okay? And so the different characteristics that we've been talking about so far apply to all of these parallelograms. And so I hope that you're thinking angles. Now I know there's some things I know about angles. Number 27, there's some things I know about the sides. And it should allow you to set up the equations pretty quickly, easily, and then solving for the variable. That's Algebra 1 stuff, so that shouldn't be too hard. So let's just take a look here. Number 26, what do we know about the angles here? Well, we know that with the opposite sides being parallel, okay, we know that this angle here and this angle here would be considered same side interior angles. Well, what do we know about same side interior angles when lines are parallel? Well, they're going to be supplementary to each other. So I'm going to set up this equation right here, 3x plus 10 plus 8x plus 5, that equals 180 degrees. Again, same side interior angles are supplementary. Okay. Now I am going to go ahead and solve for x in this one because I think it's important that we see everything that's going on here. And so if I do that, 3 and 8 gives us 11, so 11x. 10 plus 5 is 15. Okay, I just simplified what I had there. I'm going to subtract 15 from both sides, so I get 165. And then if I divide through by 11, 11 goes into 16 once with 5 left over, so I have the 5 from here and then the 5 here, 55. 11 goes into 55 5 times. So 15 times 11 is 165, so x is going to be 15 degrees there. Okay. Now how do I solve for y? There's actually one of two ways that at least that I see, and there might be more, but I'm looking at this picture. Actually, there is another way, but it's much more complicated. To solve for y. And here's the two ways that I'm thinking. These two angles, again, are same side interior angles, so they're going to be supplementary, so you could do something kind of like this, setting it equal to 180, the sum. But we also know that the opposite angles within a parallelogram are congruent, okay? And so I'm going to go ahead and set up this right here, okay, as my equation. 5y equals 8x plus 15. Just a reminder how we know that if this angle is supplementary to this angle, which they are, and if this angle is supplementary to this angle, if two angles are supplementary to the same angle, they have to be congruent to each other. And that's how we know that those are two equal angle measurements. Okay? So I'm going to go ahead and substitute in x, which is 15. So you have 5y, 15 times 8. 10 times 8 is 80. 5 times 8 is 40. 80 plus 40 is 120. So I'll put that down. And then I'm going to add those two together. So if I add those two together, I get 125. Now I'm going to divide through by 5. 5 goes into 12 once with 2 left over. So there's 2 here and there's 5 here. 5 goes into 25 5 times. So y should be 15. You know what? 5 goes into 12 twice. Sorry about that. So that should be 2. Yeah, so y should be 25 and x should be 15. I saw that both of those were the same. I'm like, no, that wasn't right. Okay, yeah, so x is 15, y is 25. I hope you didn't get confused in my last little blunder there of that problem. If we look at number 27 now, you've got opposite sides of a parallelogram are congruent. So I'm going to mark them like this and mark them like this. Now the question that I've asked you guys before is, which variable do we want to solve for first? Is it x or y? And I hope that you guys, as you look at this, would want to solve for y first because these two are equal. We can set those equal to each other. Okay. These are also congruent, but there's two different variables in one equation that it is impossible without a secondary equation. So that's what we've got here. So if we go ahead and solve for y here, subtracting 2y from both sides and adding 9, well, that was simple. Y is going to equal 11. Okay. So I then take my other set of equations. Okay, and we've got this equation here, and I can go ahead and plug in the y value. So you have 3x plus 6 is equal to 11 plus 4. And we're going to continue to work at this. So we have 15 there. We subtract 6. We get 9. Divide by 3. 9 divided by 3 is 3. So the two values for x and y in that equation, or that problem, are going to be x is 3 and y is 11. Okay? All right, now, in looking at number 28, obviously the opposite sides are congruent, so I'm going to go ahead and mark those two congruent to each other. So we know what the equation for c will have to be. 3c minus 5 equals 2c plus 3. Okay? And I'll let you guys go ahead and solve that one. I think that's pretty straightforward there. And then for the other equation for a, I know that this side here is parallel to this side here. So if I go ahead and highlight this side and that side, and I highlight the transversal between the two, the angle formed here and the angle formed here, we know are going to be congruent to each other. Why? Well, again, the lines are parallel, so if the lines are parallel, then the alternate interior angles are congruent, and that's what we have here. So I'm going to go ahead and write down the other equation, would be 2a minus 15 is equal to 4a minus 33. And then from there, guys, I just go ahead and solve for a. I know you guys can do that, so go ahead and do that for me. Okay? All right, now, for number 29, and we did have to do 29, right? Yep, 26, 29. We take it up a notch, and we look at the diagonals. Now, remember, in a parallelogram, which is what we have, the diagonals bisect each other. So the very first thing that I'm probably going to do when I have any problem that has a parallelogram and diagonals, I'm probably going to put those markings down there. Because once I have that, it makes it a lot easier to figure out how to solve for the different variables. So here are the two equations. M equals 2.6k. Then the other equation would be M plus 9.1 is equal to 4k minus 3.5. Sorry, the 5 ran off the page there, but yeah, 3.5 there. Okay? Now what can we do? Well, the good thing is that the textbook's already simplified the one equation for you. You've already got M by itself. Let's just go ahead and plug it in. So if we do that, 2.6k plus 9.1 is equal to 4k minus 3.5. Excuse me. Okay. Now, if I go ahead and add 3.5 over to this one over here, that gives me 12.6. Okay. And if I subtract 2.6k from both sides, I get 1.4k. Okay. Let's see here. That's a little bit harder than I thought it would be in my mind. Then obviously you want to divide 12.6 by 1.4, and when you do that, is it about 9? I'm not sure. 12.6 divided by 1.4. Oh, good guess. K is equal to 9. Okay. 9. So we know what K is. Now from there, if I go ahead and plug it back into the other equation, you're going to get this. M equals 2.6 times 9. And if we work on that, 2.6 times 9, 18, 5.4, 23.4. Is that right? 2.6 times 9. Bingo, 23.4. Okay. Now, I just want to remind you, when you have these more complicated problems like number 29, where you've got more steps involved, what always could be a good thing to go back and do is double check, hey, did I do my steps correctly? Because when I plug these in, we know that this is 23.4. We know that this is 23.4, okay? If I plug it into the other two sides, let's see here, M was 23.4 plus 9.1, which would be 32.5. 32.5. And if I take 4 times 9, that's 36, minus 3, that'd be 33, minus 0.5, which is also 32.5. Okay, so now I know. I plugged it back in, everything works out good, and so we're good to go. And so again, with those more complicated problems, it is good to double check to make sure you've done everything correctly, okay, those higher point values. All right, now we're going to move on to the second half of your homework from last night, which was page 307. We had numbers 7 to 11, so let's look at those first, okay? Now, I should probably double check the directions here for numbers 1 through 9, and it says that we have a rhombus. Now remember, I said that you probably want to mark out the fact that you have a rhombus every time that you do this, because I think that when you can see that these are isosceles triangles, a lot of times it can help you out, okay? And so when I look at this triangle right here, okay, this is an isosceles triangle, so the base angles have to be congruent. So I already know angle 2 has to be 35 degrees, okay? The other thing that's helpful is that all of these triangles within this rhombus are congruent to each other. So remember, the diagonals in a parallelogram, which a rhombus is a parallelogram, bisect each other. And so what we have here are 4 congruent triangles by side, side, side. And if that's the case, then this angle here, again, is going to be 90 degrees, okay? You can memorize it, okay, because we've talked about it. The diagonals of a rhombus intersect or are perpendicular to each other to form 90 degrees. Or you can just prove it to yourself over and over again because it's good analysis to be able to do that, okay? So angle 2 is again 35, angle 4 is 90. Now from there, I know that angles 1 and 3 have to be congruent to each other because they're alternate interior angles. So how do I find angles 1 or 3? Well, if I come over to this triangle right here, this angle 4, this angle is 90 degrees right here. So if I take 90 and 35, that's 125 from 180. So I'll do it right here. 180 minus 90 minus 35, 55 degrees. And so we know that angles 1 and 3, they're both 55 degrees. Makes it simple. Okay, so again, just to review, angle 1 is 55, angle 2 is 35, angle 3 is 55, and angle 4 is 90 degrees. Okay. As I look at this next problem, again, I'd probably go ahead and mark out that this is a rhombus. By now I've got it memorized that the diagonals are perpendicular, so angle 2 I already know is 90. From there, I can go ahead and say, well, I know that the alternate interior angles are congruent, and I also know that the base angles of an isosceles triangle are congruent. So if you don't have the fact that this diagonal bisects this angle, as does this diagonal bisect that angle, if you don't have that memorized, just try to prove it to yourself. Think through it logically, because it's not a very hard concept to figure out. So again, angle 1 is 60. If this is 90, then this is 30, 60, 90 triangle. You can figure that out by taking 180 minus 90 minus 60. But again, you're going to get 30 degrees. 30, 60, 90 triangles are special right triangles that we'll be talking about later on this year. Okay? And so if that's 30 degrees, again, the diagonals bisect the angles, so this is also 30 degrees. So again, angle 1 is 60, angle 2 is 90, and angle 3 is 30. Okay? I have another rhombus. I'm going to mark it out as such. Okay? I know that my diagonals are perpendicular within a rhombus, so I'm going to mark angles 1 and 3 both 90. I know that this is also 90 degrees here, if I can get it to come down. And probably what I would do, you can go 2 different routes with this, but I would probably figure out this angle first. 180 minus 90 minus 35. Okay, we did that calculation a moment ago, which is 55 degrees. Okay. From there, this angle here, because it's an isosceles triangle, will also be 55 degrees. Okay. You could also go, well, I know that the diagonal bisects the angle, so that's 35, this is 90, and figure it out that way as well. Just trying to give you some options there, but I hope that those problems were not difficult for you. Okay. Number 10, we have a rectangle, L, M, N, and P. Find the value of the length of each diagonal. Now, what did we study about the diagonals of a rectangle? Well, it's that they're congruent to each other. They're the same length. So if I have Ln, which is x, and I have MP, which is 2x minus 4, well, that makes it simple. Now I can go ahead and solve for x from there. Okay. Same thing with number 11. You have Ln, which is, again is a diagonal, 5x minus 8. MP, which is the other diagonal, is going to be 2x plus 1. And so, real simple algebra problems there. You can go ahead and finish those up for me. Okay. All right, now, for the last part of our homework here, we had numbers, 16 to 23. Okay, so I'm going to attempt to walk through this with you guys and show you how I would go about solving these. The big thing is I want to make sure I can get yes or no, this is going to be a parallelogram or not. And then I want to be able to explain why it's going to be a parallelogram, or maybe why it's not going to be a parallelogram. Okay? So the diagonals of this quadrilateral are congruent. What that tells me right now is that we have a rectangle. Okay? Rectangle. Beautiful handwriting. Not. Anyways, but the quadrilateral has no right angles. Okay? So is it possible for a parallelogram that has congruent diagonals to have no right angles? And the answer is no. And the reason is, and you'll want to write this down as your justification, because the diagonals are congruent, the quadrilateral must be a rectangle in order to be a parallelogram. Okay? However, a rectangle has 4 right angles. Since this figure has no right angles, this figure cannot exist or is impossible. You can shorten that, obviously, but I want to get across that we know it's got to be a rectangle if it's going to be a parallelogram because of the congruent diagonals. Okay. Number 17, each diagonal is 3 centimeters long with the 2 opposite sides to be 2 centimeters long. And the answer to this one would be yes. This would be a rectangle again. If it's a parallelogram, it would have to be a rectangle, just with opposite sides of 2 centimeters long and the diagonals both being 3 centimeters long. Okay. Okay. So yeah, if it's a parallelogram, then it could be a rectangle with opposite sides of 2 centimeters long and the diagonals of 3. Number 18, the 2 opposite angles are right angles, but the quadrilateral is not a rectangle. Okay? So if you picture this, the opposite angles are right angles, but the quadrilateral is not a rectangle, which means that this angle here and this angle here cannot be a right angle. Well, that tells me some major information about this figure, and that's this. If this is not a right angle, then I know that this side right here and this side right here cannot be parallel because these are same side interior angles and they must be supplementary in order for the lines to be parallel. If this isn't 90, then these 2 angles are not supplementary to each other. Okay? I can continue on and look at maybe these 2 right here. Okay? And if this is not a rectangle, then this angle cannot be a right angle. And so as a result, this angle and this angle aren't supplementary, so this line and this line cannot be parallel. Okay? So number 18 is going to be an impossible structure to be a parallelogram. Okay? Number 19, I would probably focus my eyes right here. With the diagonal bisecting the angle, that would have to be a rhombus. However, what do we see about the side lengths here? They're not congruent. And so as a result, I'm going to go ahead and say that this figure cannot exist. It's not a parallelogram. Okay? There's no way it can be a parallelogram. How far did we go down here? 3 to 23. Okay. Number 21, the big thing that I would probably look at is this right here. The fact that my alternate interior angles are not congruent to each other. that tells me that this side here and this side here cannot be parallel, and this side here and this side here cannot be parallel. So for number 20, I'm going to say that this cannot exist as far as the parallelogram is concerned. Okay. Number 21, is that possible? Well, if the diagonals are perpendicular, I know that this has to be a rhombus. Okay. If this is a parallelogram and this is a right angle, okay, that means the opposite angles have to be congruent. That would have to be a right angle. And then that the consecutive angles would have to be supplementary because they're same side interior. And so that would have to be a right angle, and this would have to be a right angle. So if it's a parallelogram, this would have to be also a rectangle. So in the end, what do I know about this structure? If it's a parallelogram, this structure would have to be a square. Now I realize this is one of those structures that's not drawn to proportion. Okay, it doesn't look like a square, but at the same time it would be a square if it were a parallelogram. Okay. Remember, the directions in this one are what make this difficult. Determine whether quadrilateral can be a parallelogram. Okay. We're not saying that it has to be a parallelogram, but can it be a parallelogram? And so that gray area of can, as opposed to being a solid yes or no, as in must be or cannot be, that's where it kind of gets a little fuzzy for some people. So I hope that made sense to you. All right, now, next thing we want to do is we want to move down to the next couple of problems here and finish this off through 23. So we have 22 and 23. Number 22 says this: you can use a simple device called a turnbuckle to square in quotation marks. What that means to square something up, I probably talked to you about this. In construction, when they say is something square, they're not asking if all the sides are the same length. What they're asking is if they form a right angle at all points. Okay. And so basically when they use the term square loosely with the quotation marks, they're really asking is it a rectangle? Okay. Why do they do that? I'm not really sure. It's just construction slang. I think that maybe at each of the angles it forms a square because a right angle symbol is a square. I'm not sure. I'm not really sure. So if any of your parents if you have parents that are in the construction business, you can ask them that question. Maybe they might know. So you can use a simple turnbuckle device to square up structures that are parallelograms. For the gate pictured at the right, you tighten or loosen the turnbuckle on the diagonal cable so that the cable stays congruent to the other diagonal. Explain why a frame that is normally rectangular will, when it sags, keep the shape of the parallelogram. Okay? Well, I think you can state a couple different ways here. And that would be this. Just because this length here is not congruent to this length here. If it were congruent, this structure ends up being a rectangle, which means the gate swings open and closes squarely, and it doesn't wedge itself. I don't know if you ever had a gate that does that, but kind of slopes to one side or another and it wedges itself. I have a couple doors at home that do that. They don't open real nice, which is a little frustrating, open or close. So the question is, when it sags, why does it still keep the shape of the parallelogram? And here's what I would say. When this sags, okay, it's still taut, okay, meaning it's still tight, but it's not equal in length to the other side. And so I would say that this diagonal is still bisected by the other diagonal, and so as a result, it still keeps the not the rectangle, but the parallelogram shape. Okay, it's just not nice and square like we'd like it to. It's going to rub when it opens and closes with the other side of the gate. Okay. Number 23, a carpenter is building a bookcase. How can she use a tape measure to check that the bookshelf is rectangular? Justify your answer and name the theorem used. Okay, we've talked about this already. She can determine if the diagonals are congruent. Okay, from one corner to the opposite corner, is that length equal to one corner to the other opposite corner, okay? And so as a result, if the diagonals are congruent, that means that the book shape is rectangular, bookcase, sorry, is rectangular, and the builder has done a good job, okay? All right, from there I hope that was understandable, so you have a little bit of a lesson to work on there, folks. I believe you're going to be working on a worksheet for me, so that is due on Monday. So I hope you have a great weekend, and I'll see you on Monday. Good night.